Mark, we're here at the University of Nottingham. What is it you do here?
So at the Precision Manufacturing Centre we do a variety of different projects. We do some commercial machining, we do applied research, and we do local business assists through a European Regional Development project.
And what does that mean in layman's terms?
So we cover a multitude of bases. From the commercial machining perspective, we focus on very, very small batch production to say sub 50 quantity parts, but usually it's one-offs, prototyping, in difficult materials, extremely tight tolerances, mostly that other companies or commercial companies that do large production work wouldn't really want to get involved in at this stage. So we currently run a European Regional Development Fund project. This is to assist and enable local businesses in Nottinghamshire and Derbyshire. So if you have a Nottingham or Derbyshire postcode, all the facilities at Nottingham University Precision Manufacturing Centre are available to you for at least or a minimum of 2 days as a free assist. So I can't stress that enough, it's free. All this equipment that we're going to look at and talk about, KERN, spinner, Hermley, all available. We also got design, rapid prototyping, design for manufacture is a one that crops up a lot with that sort of work. So if you are a local business, it doesn't have to be primarily machining topics that we can cover. We're happy to get involved in any stage of development or process development.
What type of parts are they typically?
Commercially, we do medical, aerospace, luxury goods, let's say. Wherever ultra precision is required, that's our market. So there's not one particular sector that we're overly stretched into, but we cover lots and lots.
Speaking of precision, we're stood in front of a KERN machine. Why did the university select KERN?
Initially, KERN was selected to manufacture micro-injection moulding tools. We'd recently invested in a Battenfeld microsystems machine, and the Professor Rachev, who's my supervisor, he selected the equipment. He went out to KERN in Germany, very involved, really liked the company at the time, and he thought this would be the perfect partner to make the micro-injection moulding tools. As the business has progressed over the years, we've not really got too heavily involved in the injection mould tool side of things, and mainly moved into the precision manufacturing components, and that's where we find our biggest market. That's where it currently spends most of its time manufacturing.
So what is it on the machine you like? What features?
It's an easy to use 520 control, so that's relatively easy to use, but having worked large heavy duty machines in the past, coming to KERN was a little bit of a culture shock in terms of how you need to approach machining with it. It's not all about volume stock removal, it is purely for finishing, but it makes finishing very, very easy. So jobs where you'd be chasing 25 microns, 20 microns, constantly altering parameters all day long, never an issue. And this carries on down into sub 10 micron machining in hard materials, stuff that traditionally you would be having nightmares about. And the machine makes it not effortless, but much, much simpler. And you can rely on it to do a job day in, day out for you at that level.
So it's sub 10 microns, even using the table, the 5 axes?
Yeah. I mean, obviously, when anybody quotes figures on machining accuracies on parts, or they're often quoting positions on a stage, we can achieve sub 5 microns on a 5-axis part. And if you want to do point-to-point machining, jig boring holes, for example, you would be probably sub 2 microns without any fuss. This is on the part, taking into consideration deflection, tool wear, and everything else. So that's a bit of a dream really come true for a machinist, that you can achieve this sort of level of precision without having to go, constantly adjusting your machine and fighting the machine almost to get there.
And it's a very good machine, it's a precision machine, but it's only as good as the cutting tools you put in the spindle. And I know Rainford Precision are the agents for KERN, but they also supply cutting tools for you as well.
They do, yeah. We've tried cutting tools from a variety of different sources, and if you're doing general work, you can get cutting tools from anywhere. But a lot of what we do, where we're looking for forms of 5 microns on a part, on a 3D surface, you need to know the shape of your tool is exactly right. Not every supplier that we can find sells these. Union Tool, and supplied through Rainford, can supply us with bore noses that are calibrated, come with a measurement report, and we use those for our really detailed work.
So the end mill actually comes with a certificate of conformity. I've never seen that before.
It'll come with a printout on, I think the Super Excellent series is that particular one. It comes with a form printout of the ball and the effective cutting radius that's been measured.
That's important. So whatever's on the CAD, whatever's input into the control, is going to be on the part.
Absolutely, yeah. When we're doing strategies on our CAM system, we need to know exactly the shape, the size of the tool that we're going to do, or we're going to get nowhere near the tolerances, even if the machine is capable.
Laureline, it's your final year here on your PhD. What have you been studying?
I have been doing a study on improving micromachining precision. So I have been studying micromilling, micro-turning, and I've looked at different aspects of it. So I've looked at how the machining center influences my cutting precision. I've done studies on the KERN and on other machines, and I've pretty much found that the KERN takes out all the vibration. It's so good at damping it that it doesn't influence my precision at all. So I've done the same experiment on different machines, and I always come back to the KERN because in order to study the very fine surface roughness, surface precision, tool workpiece interaction, it's best to take vibration, the dynamic effect out, and KERN is perfect for this.
The machine, that's great news for KERN. How important is the cutting tool?
It is massively important. So from my experience, the cutting tool is so sensitive and is the most expensive bit of the entire machining process. So by improving, perfecting the cutting conditions, you can save tool life, you can improve tool wear. I think that it's very difficult in micro-cutting to get the best surface roughness and the best and the really good surface form surface contour without the proper tool. So I think tooling is very effective, especially when used on the proper machine.
So you've got a KERN supplied by Rainford Precision and also your cutting tools supplied by Rainford Precision. So they really are the experts in micro machining.
Yes, and I was lucky enough to see a few of the KERN engineers coming and seeing it and seeing how well built this machine is. So you know, the more interacting equipment you have inside, the more errors you get. So from a research point of view, you want to minimize errors, and the KERN is so smoothly designed and prototyped that it has very little bearings. It has a very nice pneumatic driving system, so it's really good at minimizing all the errors coming from it.